You often hear it announced that this or that recent year was the hottest year ever. But how far back is ever? The modern mercury thermometer was invented by Daniel Fahrenheit in the early 1700s, and it wasn't until the mid-1800s that systematic weather records began being collected around the world. But even then, it was mainly in Europe and the US, with a few scattered places on other continents. By 1900, more places were recording temperatures, but for the world as a whole over the 20th century, there are reliable records for less than 50% of the Earth's surface, especially over the oceans. Here in Canada, while some places have data back to the late 1800s, official Canada-wide weather records only begin in 1948. The world's atmosphere now has complete coverage from weather satellites, but that record only starts in 1979.
So, the hottest year ever is not since the world began or even since the end of the last ice age. It's more like since a few decades ago. So you might ask, what evidence exists that it was as warm or warmer than today in past centuries before thermometers were invented? And I'm glad you asked, because for the Climate Discussion Nexus, I'm John Robson, and this is a CDN backgrounder video on past climate warming episodes.
When we try to figure out what happened to the climate in the distant past, we have to decipher indirect clues left behind in things like tree rings, sediment layers in lake beds, deep ice cores, movements of tree lines across the landscape, and even observations in ancient writings. It's a fuzzy, grainy picture, and it leaves out a lot of important detail.
I mean, it would be like trying to reconstruct all of 20th century US history from Hollywood films. You'd get some things right, but you'd leave out a lot, and you'd have to rely on a lot of guesswork. But no matter how uncertain the science of climate reconstruction is, one thing that emerges very clearly is that the climate is not stable. It has a long and complex pattern of warming and cooling that, throughout the history of our planet, has seen temperatures most of the time higher than today. And until we can explain why it used to be so much warmer than it is now, we shouldn't assume that we know what's behind any warming we're currently observing or have seen in the last 50 or even 100 years.
Here's a quick overview of the past 500,000 years, as recorded in ice core layers in Antarctica. Scientists look at the chemical composition of each layer of ice and infer what the air temperature likely was when the layer formed. What we see are repeating patterns of cold conditions that last for about 100,000 years, interrupted by warm conditions that last for about 10,000 years. The current warm period, called the Holocene, is noticeably cooler than the previous 4. And here's a close-up of Holocene temperatures as recorded by ice core layers in Greenland. Notice that the climate warmed rapidly as the Ice Age ended and reached a peak warming in an interval called the Holocene Climatic Optimum between 8,000 and 7,000 years ago. Ever since then, it's gradually been cooling, except for the Minoan warm period 3,000 years ago, the Roman warm period 2,000 years ago, the medieval warm period 1,000 years ago, and the modern warm period.
Now, I should mention that that chart has been criticized because the elevation of the ice cap changed over time and an adjustment needs to be made to correct for it. So here's another Greenland chart from elevation-adjusted records covering the same time interval.
While that record is noisier, the same periodic warming and cooling events are there. If anything, it shows a stronger overall cooling trend since the mid-Holocene period, and it shows that it's been underway now for about 9,000 years. For those who insist the world is warmer today than ever before, the biggest problem isn't just the periodic warming and cooling episodes over the past 9 millennia. It's the Holocene Climatic Optimum itself. Not just because its name suggests a belief that warmth is good, but because this episode was so much warmer than today. And it gives us some insight, if we care to look, into what a warmer world would look like.
Do we see runaway warming, a greenhouse effect, extreme weather, crop failure? Do we see hurricanes, wildfires, floods, and droughts causing mass extinction, coral reefs dying along with polar bears? No, we don't see anything of the sort. So we can refute predictions of catastrophes to come if it goes up by another degree by looking at the past that already came, where it was more than a degree warmer, and we find that the Holocene Climatic Optimum was indeed optimal for life, including the Sahara being a moist and verdant land of charismatic megafauna, and humans spreading and flourishing as agriculture took hold. Here we're not even getting into what happened before the Pleistocene Ice Age began around 2.5 million years ago. But we do encourage you to look into it and see that an Earth far warmer even than the Holocene Climatic Optimum was also very hospitable to life, not Al Gore's nature hike through the Book of Revelation. And you'll also find that there is really no correlation between carbon dioxide in the atmosphere and temperature through almost all of it. That is important. But the Holocene alone, a brief and unusually chilly slice of our planet's history, tells enough of a story all by itself. And now, a word from our sponsor. And yes, it's still you. And we want to thank all the people who've responded to our appeals by making a one-time or monthly pledge. For the rest of you, I really want to emphasize, for us to produce the videos, for us to produce the newsletters, and keep injecting sanity into the climate debate, what we need is for 1 in 6 of our YouTube subscribers to click here and make a pledge of $2 a month, $3 a month, $5 a month. That's what it's going to take to sustain our efforts for as long as they're needed. So click here, cup of coffee a month, that'll keep us in business.
Within the Holocene, if you look closely, you'll see that very early in the current interglacial warming, there's a sudden drastic shift called the Younger Dryas event, which was a dramatic cooling after an even more dramatic warming, larger and faster than anything we're seeing now. And it all occurred thousands of years before humans started using fossil fuels.
Now, let's step away from the deep ice cores for a moment and ask what other clues we have about past climates. One, after writing is invented, is written records. Not primarily of it being hot or cold at some time or another, but agricultural records reflecting amounts collected in tithes, things that indicate where grain or other crops were growing well or poorly. And also things like the Viking voyages to and settlements in places like Iceland and Greenland, which even if the latter name reflected wishful thinking or PR rather than accurate reporting, certainly did happen and led to flourishing farming communities that later shrank or, in Greenland's case, disappeared as temperatures fell after 1300.
The other is physical proxies, such as tree lines moving north and south and up and down hills and mountains, indicating warmer and cooler periods. For instance, a 1997 study of remains of black spruce buried in northern Quebec suggests that it was warm enough for a forest to grow there for at least 1,800 years prior to the mid-1500s, but ever since, it's been too cold.
So there you have it. If someone tells you that some recent year is the hottest ever, it's like a clock striking 13. It calls into question everything you've heard from them before and everything they're going to say afterward. That year was far cooler than the Eocene, the Paleocene, or the Mesozoic. It may not even be the hottest in the last century, given the 1930s unadjusted version. It's very likely not the hottest in the last 1,000 years, given the medieval warm period, and it's certainly nowhere near as hot as the Holocene Climatic Optimum. Hottest year ever? Phooey. For the Climate Discussion Nexus, I'm John Robson, and that's our backgrounder on past warming periods.